If it disagrees with experiment, it's wrong. And that simple statement is the key to science. It doesn't make a difference how beautiful your guess is. It doesn't make a difference how smart you are who made the guess or what his name is. If it disagrees with experiment, it's wrong.
Yeah, look, they said that I couldn't do it, so I went and did it. W's only, you know I've been winning. Top of the world, the globe is spinning. If you know, you know, I've been on a mission. Go.
To always have a cause and effect.
Yes.
Okay. So you disagree with Feynman?
Well, I can agree that, causes, or there must be causes and there must be effects and they're tied together, but that doesn't mean that I disagree or that I agree that it has to make sense to you individually.
Wait. That's impossible. That's a contradiction.
No, it's not.
Yeah, I think it is. So,
Yeah.
So you're saying that there is a cause and effect, and I'm going to look at a cause and an effect and not understand that I'm seeing a cause and effect. That's what you're telling me. That's what you just said.
I mean, what about modern physics says that causes don't precede effects?
Causes don't precede effects? What do you mean?
Like that.
Mhm.
Like what about big physics disagrees with the fact that causes don't precede effects?
I mean, I disagree with big physics because big physics, they always say, all the science communicators, they always say, the universe is under no obligation for you to understand it. I disagree with that. I claim that the universe, the definition of science is the assumption that the universe is mechanical, simple, intuitive to a child. So I disagree with big science about what is science. And the day I understood the definition of science the way I understand it now, that's when I realized everything. That's when everything started falling into place. That's when
When was that?
You are very wrong on that.
I'm very wrong about what?
You're very
Most
wrong on
everything.
most everything, but that the universe is simple. It's not always simple, and nobody in science ever says that there's some obligation of anything. It just so happens that we see patterns in the universe, and those patterns in nature seem to be understandable. They may not be simple, but they do appear to be rational.
Yeah, seems to be is the best explanation for most stuff.
Yes,
Like,
unless we come across a miracle, which a miracle would literally defy all of natural study, and seem to have no pattern, no connection, which we have not yet had happen. Religious convictions notwithstanding. So far, science has never ever seen a miracle happen.
So the definition. Let's break it down. So it's difficult to define, but I would say the definition of a miracle is the avoidance of the relationship of the cause and effect, is the violation of causality. I would say that's the definition. You are welcome to agree or disagree. Tell me what your definition is. But I would say the definition of a miracle of anti-science is the violation of causality. And so, look, if you agree that the universe is mechanical, that the universe is causal, if you agree that causality, okay, then you're a religionist. You believe in ghosts.
Incorrect.
You're wrong.
Look, it's
Just
down.
because you don't understand stuff doesn't mean it's fake.
No. What I'm saying, if you No, we can both not understand a phenomenon. I'm not talking about not understanding. I'm saying, what is the assumption of science? What's the definition of science? I'm saying the definition of. By the way, you can hear me, right? So obviously, definition of science is the assumption that the universe is simple, mechanical, intuitive to a child. That's my definition of science.
Yes, and you're
It
very
might
wrong.
be
Then your definition is incorrect.
well, it's
Yeah,
my
I don't even
definition.
understand it, so that's I'm close enough to think like a child.
What?
What about Feynman's famous quote? If you think you understand quantum mechanics, you don't understand quantum mechanics.
Yes,
Yeah,
very, very non-intuitive.
yeah. And the day I decided to disagree with Feynman, the day I decided that that is a nonsensical, that is a religionist, that is a that whoever believes that statement believes in ghosts. Ghosts are downstream from that. All the cults. Look at how many cults
Worship
have.
quantum mechanics.
Look at how many cults started from quantum mechanics or use quantum mechanics to.
No cult uses quantum mechanics.
They all
Sorry.
do. They all
No,
do. They
incorrect.
all. Everyone.
No, incorrect. Very few sciences are based in quantum mechanics. So you can go through biology all day and rarely talk about quantum mechanics unless you really get
No.
into biochemistry.
Cults. Religions. Cults.
No. Religious cults could give a shit about quantum mechanics. You'll not see any
No.
place in I don't know, Lutheran doctrine about quantum mechanics.
Anyway. Okay. I'm not. That's. I don't consider that a cult, but there's so much woo-woo based on quantum mechanics. Quantum mechanics is given.
Only because you don't understand it seriously. There's very little woo in quantum mechanics. It's all based on equations. Does it make a lot of sense intuitively? No. Does it work? Yes, it works very well. Thank you.
Yeah, just because Deepak Chopra unloads a whole lot of quantum bullshit, which he calls quantum but really isn't, does not mean that quantum mechanics is in any way religious. By the way,
Anyway.
you are, in my mind, you are sitting right next to Deepak Chopra.
No, you are Deepak Chopra.
Sure.
I'm showing you are Deepak.
I am Deepak Chopra.
Is there
There
more
you go.
who than woo in
I
there?
am Deepak Chopra.
I am Deepak Chopra.
And I'm his good friend Jesus.
Sean, what do you think? Are you listening?
Who's Sean?
Sean.
I don't care who
Anyway.
he is, as long as he shouts beers.
What? Anyway, so
Wait a minute,
you
hold on.
are.
So you think you should be able to intuitively understand quantum mechanics?
I do.
You do?
I happen
You
to
intuitively
completely.
understand quantum mechanics. Oh, please tell
Yeah.
me about this. I would love to be able to understand quantum mechanics at an intuitive level. Go.
Ask me questions. Ask me
Explain
anything.
the double slit experiment.
That's trivial.
It's trivial. Explain to me why, when you observe it, the waveform collapses.
It doesn't. It's always a
does.
wave. No, it doesn't.
It does. It collapses
No.
into, whenever you observe it, it collapses into two bars like they're particles. If you don't observe it, it goes back into the wave. Why?
No, because you block one path. Anyway, it still
Incorrect.
behaves. Like,
No. We don't block a path. We just observe it.
how do you observe? You don't interfere with one of the paths?
No, we don't interfere. We just notice which one it goes through.
What do you mean you notice? How do you notice?
Or you measure it.
How do you notice? Tell me about your device. How do you notice? How do you notice? Tell me about the actual device that is used
Well, it's
to
not
notice.
blocking anything. It's just counting which one it goes through.
So I would claim that you're interfering, you're blocking. Look, the
No,
way it
not
works.
blocking. No blocking involved.
Then tell me, fine. Then tell me about your equipment. Tell me about.
The simple one to understand is when you polarize light.
We're talking about the double slit experiment.
Yeah. You can do that. You can do the quantum eraser in your house if you want to.
Wait, I'm not talking about. I'm talking about the simple double slit experiment. Let's talk about the. You want to talk about the photon one or the electron one?
Either one.
Let's go with the photon one. All right. What's the
I
question?
just want to say, because I'm really proud of this, I've managed to do the double slit experiment using a laser and a human hair.
Yes, yes, I've seen that done. Yeah, 'cause, you know,
I did it with the sunlight in full color.
Yeah, but
yeah, that was a little bit less because the wavelengths are different, right? But it still gives you
yeah,
the
but
same effect.
the
Beautiful.
Hey,
doubles.
hey, don't diss my accomplishment by saying that you have a better accomplishment.
I know, I understand. It's possible to be done.
Anyway, back to your questions about quantum mechanics. Ask me anything.
Explain quantum mechanics in 25 words or less. Go.
What's the question? Ask me a question. What
Right.
don't you
The question is,
understand?
explain to me how quantum mechanics work in 25 words or less.
You want to talk about the double slit experiment or no?
Yeah, how's it work when I observe going through one? When I'm not looking, it gets the wave, but if you observe what slot it goes through, you can.
What do you mean observe it? Tell me about the mechanism that you use to observe it.
You can polarize the light and then come
What do you
back.
mean?
Hey guys,
What do you mean polarize the light? What do
check
you
out
mean?
the general chat from my full color sunlight double slit experiment.
That's cool.
Whoa.
Yeah, you get a little
I'd
bit
use
overlap
that as
with
a
the physics
screensaver.
there.
That's good enough for a screensaver, that one.
I like the first one's the overlay, right? And then you break it into various wavelengths.
Yeah, the first one is just the image from the CD sensor on my camera, my DSLR. Because I took the lens off and I put the double slit on the front of my DSLR.
That's not a single photon.
Well, so I stretched it. Let me get you a section of the actual single photo.
Single
Photo.
photon.
No,
Single
that's not a
photon.
single photon version there that Jesse has. Jesse hasn't done it with single photons.
So if you don't do it with a single the whole point of the double slit was to prove that a single photon interferes with itself. Otherwise, like if you just assume it's waves, then it's just waves, then there's no question.
So it's
So
not waves. If you want to go particles, then you have to shoot single electrons at. That's a little bit more difficult.
okay, so you how are you detecting without interfering? Polarizing it?
Well, if you want
Putting
to talk single particles, it's a little more complicated.
I think the more interesting question that would probably put what you're trying to say in better relief would be to explain how it is in quantum mechanics that the solution to the ultraviolet catastrophe and the double slit and the solution to the double slit experiment can work together in an easily explainable way.
what's the question?
Your
Why is there
mother.
even a question? Wait, so which experiment do you want to discuss?
Okay,
Like,
so first, do you know what the ultraviolet catastrophe is?
pretty much, sure.
Okay, so you know what that is. Good. All right, and you know what the double slit experiment is, correct?
Wait, I don't
Pretty
know what
much.
the ultraviolet catastrophe is. Explain.
Okay, so the ultraviolet catastrophe deals with black body radiation. If you have a radiating black body source, and as you heat it up, you get a light curve. Okay. Um, if you use the assumption that light is a wave and therefore infinitely divisible, you get a different predicted curve than what you actually get. The whole reason we call quantum mechanics quantum is because the solution to the ultraviolet catastrophe was to quantize light and say that it can only exist at discrete energy levels, ergo, particles. Quantum mechanics originates from trying to find solutions to the ultraviolet catastrophe.
And the reason it was called the ultraviolet catastrophe is that as you increase shorten the wavelength, increase the frequency of the light, it carries more energy. And even though there is less of it, the predictions from the naive wave model were essentially, if you integrated up to infinite wavelength, you ended up with infinite energy instead of tailing off in a correct manner to what was observed experimentally. That
Yeah,
was
so
the thing. There was a consequence. The Rayleigh-Jeans law was one of the ones that was trying to answer it, and that one had the catastrophe at the high energies.
yeah, and so the basic problem with trying to have an easily understandable explanation for both the double slit experiment and the ultraviolet catastrophe is because the double slit experiment basically makes a statement that light operates as a wave. The ultraviolet catastrophe says it operates as a particle. These, under normal macroscale circumstances, are two mutually incompatible categories for something to exist within. That is what my opinion as to why quantum mechanics can, well, that and indeterminacy, so difficult to understand.
Hmm. Anyway, for me, I don't even see the question. But let's go step by step. So so for me, everything is a wave.
Well, you're
Let's see
incorrect.
how.
You're
Then you're
incorrect
in,
because
yeah.
of the photoelectric effect.
Right. So let's
If
go.
you say everything is a wave, then you are in contradiction to the ultraviolet catastrophe.
And the electrons. Electrons are particles, and we can fire them at the double slit and get a wave function. How's that work?
Because it's a wave. But let's
No,
go
it's
step by
not. No, they're
step.
particles.
You just
They're
said it's a
particles.
wave. Fine. Look, you just
They're
said it's a
both.
wave.
They're photons. See, the problem is photons are both, and you are.
Anyway, let me complete a sentence. Then you can
Wait, hold on a
react.
second. When you say everything is a wave, you have been proven to be incorrect by science. Okay, I'll shut up here in a second, so Sean.
Yeah, be quiet because I want to hear him explain
Okay,
how
fine.
everything being a wave, specifically light being a wave, works with the ultraviolet catastrophe. Because remember, he said he knows the ultraviolet catastrophe, so he would have already thought of how a wave function, well, a wave can operate and produce the real measured light curve that we see from black body objects.
Right. So I mean, certainly today that we have Bohr's model. We can use Bohr's model to understand it. So
Bohr's
Basic-
model? Are you serious?
yeah,
Let him cook, NASA.
NASA
yeah.
shut the fuck up.
Yeah, let him continue. Let him
Yeah.
continue.
Yeah. Anyway, so we're gonna use Bohr's model. I think it's the simplest, the best. Anyway, so with the ultraviolet catastrophe, so you're heating up an element, like let's say hydrogen. So you're heating up hydrogen. You're causing the electron to go up in orbit, and then it's unstable. It drops in orbit, and it causes a vibration. Now this vibration is just an electromagnetic wave. It's a tiny amount. It's exactly the amount of the energy of the dropping of the electron from orbit, let's say 2 to 1, the lowest. That vibration is what we call a photon. It's a wave. But it's a special type of wave. We call it a wave packet. It's a wave with a direction, with a momentum, with a location, delta x, but it's a wave. It's a wave packet. So, but it is right because of basically de Broglie. From de Broglie, we have the lambda, the wavelength of the electron. So
May
Bohr
I
said, yeah, go ahead.
may I ask a question in regards
Sure,
to what
sure.
you just said about
Well, hold on.
Bohr's
Let me just
model?
repeat
And
something real quick, which is that MrSlave legitimately thinks that electrons do orbit nucleuses. You can go on.
okay, so are you okay if I ask a question in regards to what you just said?
Sure.
All right. So one of the fundamental principles of waves is that they are essentially infinitely divisible, and there is no quantization. If you go from one wavelength, it is perfectly smooth without break to another given wavelength. How do you get to the quantization that is required, as far as we know thus far, to solve the ultraviolet catastrophe?
That was exactly my next sentence. So de Broglie gave us from the momentum. Anyway, from de Broglie we have the wavelength of the electron, and Bohr said that the electron can only orbit in an integral multiple of the wavelength. So n equals 1 is the original wavelength, and then you can go to n equals 2 and so on. But that means that when the electron creates a wave, it can only create a wave that is quantized from orbit 2 to orbit 1. There is no other way to create a photon. There simply is no other way in nature that I'm aware of. Create a smaller bit of energy, a smaller wave, and that is what causes the quantization. So maybe the photon, maybe we can create half a photon if we had, I don't know, a different universe. But in this universe where we have electrons creating photons as they fall from orbit 2 to orbit 1 and they smack against the lowest energy level, that smacking, I was just imagining, like take a rubber band, put it around your wrist, open it up, and then let it go all at once. As it snaps onto your wrist all at once, it creates a shock wave. That's the photon. Anyway, so it's quantized. It's not quantized as a particle. It's a quantized wave. So,
Okay.
but it's a
So,
wave.
so can plasmas generate light?
What's a plasma?
Plasmas are generally, okay, let's see if I can properly define this. A plasma is a state of matter where the electrons are decoupled from the protons. Is that accurate? Can anybody else make that more clear than what I just said?
Sounds about right.
Yeah.
Okay.
It sounds like a free electron. So a free electron, as far as I know, I don't know. I don't know anything about the mechanics of free electrons. I don't know. But what I do know about the UV catastrophe, that's the explanation. It's very simple. It's like you can theoretically divide a wave as much as you want, but nature doesn't produce these any size you want waves. It produces, the only way to produce a photon that I know of is by an electron dropping orbits, and then you get these very specific waves or wave packets.
Sorry, but you're wrong there.
Mm-hmm. What?
You know, you can produce energy at different energy levels other than the quantized states of individual atoms.
Okay, how?
Have you heard of particle accelerators? That's how.
So what you're saying that it's possible to create half a photon?
No, I'm saying that you can produce a photon at almost any any arbitrary wavelength that you want, even the ones, including the ones that are not a nice integer multiple of what you're calling the energy levels.
Yeah, there are other ways aside from jumping energy levels in an atom for generating this. The one I was getting to, and I didn't even think about the particle accelerators, but yeah, that would do it. I was more thinking about the fact that the electron in plasmas is decoupled. So a prediction of what MrSlave here is saying is that the light generated from a plasma would not follow the same predictions that the quantized black body predictions give. I'd like to see him prove that.
Wait, but look, we're dealing with a specific experiment. The UV catastrophe is a very specific experiment. And the reason why they were getting the graph that they were getting is the way I'm explaining it, and I don't see the issue. Just
Well,
thinking.
you're making a prediction that if we could generate light without it being generated from an atom of some kind, then you would be able to essentially have infinitely divisible scales between wavelengths. There
I
would be
wouldn't
no
say.
quantization in it, because you're saying that the quantization that was found is a product of electrons jumping energy levels. We have now given you two different methods that light can be generated without you requiring electrons jumping energy levels in an atom. So can you now show us, using this new knowledge that you may have, that you don't need atoms to produce light, that under certain circumstances, the equation for quantized black body radiation, i.e. the answer to the ultraviolet catastrophe, does not hold under these circumstances?
I lost you completely. Can you ask a smaller, simpler question?
Brutal.
Did
Let's
I
talk about
lose
the U.
anybody else?
Let's talk about
Yeah, I
just the
could
UV.
follow.
Let's just
Okay.
talk about the. Let's just talk
Can
about the
you?
UV. Let's just talk about the UV catastrophe. Let's finish that.
We're
So the
still
UV.
talking about that.
Okay.
Totoro,
Listen.
would you be able to explain in more simpler terms what I just said? I'm eating dinner while we do this, and maybe you'll have better luck.
Why
I
are
mean,
you
you
so
prefer.
mean? Why be so mean?
You wanted you wanted your theories tested. We're testing them. Don't cry foul.
No, no,
And
no.
I'm
There's
not
no.
being mean. This is just how I am when I'm talking about technical subjects. So I apologize if I seem mean, but this is not me being mean.
Yeah, no, you're being super nice actually.
Yeah, so
No,
the
no.
cool part about the ultraviolet catastrophe is every time you make a piece of toast, you are using basically quantum theory there.
Anyway, going back to the discussion. First, please, everybody, don't be mean. There's no reason to be
Okay,
mean.
okay, get over it.
Just be nice. Anyway, so okay, let's just talk. Let's forget about plasma and particle accelerators for now. I don't want to um, I don't want to talk about too many things. Just talk about UV catastrophe experiment. Explain that with a wave, and then we'll go to the double slit experiment. Explain that with a wave, and show there's no contradiction. Both are waves. Everything's fine. So UV catastrophe. So so waves are not infinitely divisible when you heat up, let's say, hydrogen or any chemical, because the electrons, you need to cause the electrons to fall specific orbits, so you get waves, and but you get them in packets. So you get quantized waves. These waves have location, direction, and momentum. So they're not particles. There's nothing moving through space. There's something waving through space, but there's nothing moving. Photon is not. The photon is moving, but there's no particles of photon moving. Rather, it's an electromagnetic disturbance that is propagating, just like any other wave. But it's
And
a.
how do you
Can
explain
I?
the
Hold on,
total?
let him
I thought he was
continue.
done. I thought he's not done.
Well, no,
No,
he
not
said
not
he wants to talk about the double slit experiment. I was going to let him ramble for a little while and get
wait.
into the double slit experiment, and then I was going to bring him back and ask him
Felkami,
about the
Felkami, Felkami.
Photoelectric effect.
hold on. No,
Felkami,
well,
Felkami,
more
don't say
about.
ramble. Felkami, don't say ramble. Come on, don't be mean, please. Stop it. Just be nice. There's no reason to be so
Okay,
mean.
I admit I was being mean when I
It's
said
fine.
rambling, but it's a little bit aggravating to hear you say the same thing 3 times and then tell
I'm
people
sorry.
to just
Then
listen.
I didn't tell anyone to just listen. I always stop when I'm stopped. And I'm sorry if I'm repeating. I'm sorry if I'm being mean. Okay, let's de-escalate. Everything is fine. What do you want me to do now? Does anyone want me to do, to talk, to not talk, explain, not explain, repeat,
Well,
not repeat?
um, what I'm really interested in regards to your theory of everything, and I'm not saying theory of everything to be mean. That's how I've heard people describe what you're saying.
Yeah,
And so that's a
it's
term
fine.
that is officially out there.
Yes, it's fine.
Okay. I'm still intrigued by the fact that you said that the only reason that light is quantized for the ultraviolet catastrophe is because it is generated by jumping energy levels in an atom.
Hmm.
But the implication of that is if you can generate light without it being generated from jumping energy levels in an atom, it should
Hmm.
not be quantized. The implication of that
Wait, then
is that
how?
it should then diverge
Wait, stop. Hold
from.
on.
Okay.
No, yeah, hold on. So when you say so, give me an example. How would you create a vibration in the electromagnetic field?
Well, we've given you two examples.
Yeah. So yeah, take one of them and let's go through it. So which pick one and let's discuss it.
Okay. So the one that has an official formal name is synchrotron radiation, which is what Totoro was talking about previously.
Yep.
With the okay. Now the one that is much more
No,
manageable for you to produce, so that you can actually test your theories,
no.
would be plasma.
Okay. Pick one and let's discuss the details. So plasma or
Okay.
synchrotron, what's your preference?
Let's go synchrotron because it is more well understood and pretty thoroughly measured, and that'll also get you and Totoro talking, and me
Okay.
eating.
Okay. So can somebody explain to me synchrotron, whatever?
Synchrotron radiation.
Synchrotron radiation. What is that?
That's what happens. It's a kind of electromagnetic emission that happens when a charged particle is accelerated. And it is
Uh,
proportional to the, well, it's essentially proportional to the kinetic energy of the particle.
Isn't that the Lorentz force, or?
Well, you accelerate a charged particle by using a Lorentz force, but
Oh, Lorentz force is velocity, and that's acceleration, or?
Lorentz force is the force that a charged particle experiences when it is inside of an electric and or magnetic field.
Yeah, yeah, yeah.
the question is, so okay, so we all agree electromagnetic radiation is a wave, yes or no? 'Cause that's the crux of the debate, right? That's what we're
What
discussing.
No.
is the question? Is the electron a wave or no? Is
No,
that
no, I said electron. I meant the EM wave. We all agree that EM wave is a wave, right? The
No.
photon is a wave.
electromagnetism can be viewed as both particles and waves,
Okay, when you
depending
say
upon certain circumstances. If you want to be super duper technical, it is a disturbance in a particular underlying structure called the electromagnetic field, but that gets into some heavy QM.
okay, so I was asked to explain the UV catastrophe and the double slit experiment and to show that there's no contradiction. So I said they're all waves and that explains everything. And then I was challenged. So could somebody ask me questions? Because I think I answered all the questions. I don't think there was a question. So please ask
Well,
me.
the criticism we have is your explanation for the ultraviolet catastrophe does not bear fruit. Because the ultraviolet catastrophe has not proven to be wrong even at very high energy levels. And those energy levels being where the electron or some particle is generating light without being part of an atom. The
No,
synchrotron.
no,
So let me
no,
see if I can better explain synchrotron radiation to you, because I'm not sure that Totoro's explanation was sufficient. So synchrotron radiation is a real thing that particle colliders have to deal with, And yes, it is the tendency for an electron that is accelerated to high velocities to produce radiation of varying types. But the reason we call it synchrotron radiation is because it has been most documented early on in a type of particle collider called a synchrotron, which is basically the particle colliders you see that are giant rings. Because when you use a magnet to change the direction of the electron, that is essentially an acceleration that produces X-rays.
I'm lost. I'm sorry. I'm
I
sorry,
don't
but
know. I'm sorry, I don't know how to explain it more simply, but if you have an electron traveling at very high velocity and you change
no,
its direction, it
no, no,
produces
no,
X-rays.
no. I'm lost as to what's the question. I was asked a question about. Like, I was asked, can I explain quantum mechanics? I
Is
said, hold
is
on, hold on.
English your second language?
Hold on. So I was asked to explain quantum mechanics. I said I understand it thoroughly. Ask me anything. So let's maybe start over. So does anyone have any
Okay.
questions about quantum mechanics? Does anyone not understand quantum mechanics?
Have you changed your opinion on understanding quantum mechanics thoroughly now that you realize that your assumptions about the ultraviolet catastrophe are wrong?
Okay, I'll ask again because I don't know what you're talking about. So does anyone have any questions about quantum mechanics? Yes or no? You have a question about quantum mechanics?
Whistled right past it.
Yeah,
Let's
I haven't got any questions because I don't understand it in the first place. So.
So
let's
does
go
anyone?
back to the double slit experiment. Single photon
Sure.
version, single emission, and yet it produces an interference pattern, but it only
Mhm.
impacts the target at one spot. Explain.
Well, it's a wave packet. It's a wave. It's a tiny wave. It apparently goes through two slits, but after it goes through the two slits and interferes with itself, it's still one
How?
packet
How did it go through two slits?
as a wave. Good look, it's a good question. So it's going through two
But it only
slits.
ever impacts in one spot. And the
I
pattern
don't
that
mean,
they make after you fire enough of them produce an interference pattern, but they only ever, when you actually run the thing, impact in individual points. Explain.
right. So look, it seemed look, all I can do is look at this experiment and tell you what I can imagine is happening mechanically. So what's happening is there is a wave packet that is a photon. It has a certain size. It goes through the two slits. As it's going through the two slits, it's still one thing. And
So your wave packet that is supposed to have a position now has two positions. It goes through both slits at the same time.
right, but it's big enough that as it's going through both slits at the yes, it's
But
going
when
through
it
both
but
slits.
when it
Yeah.
impacts at the other side, it is much smaller than the separation between the two slits. So how did it span itself out just to go through both slits, and then it recompactified itself just to hit the detector at one spot? Seems to be
That's a
doing
good
a lot of a lot of knowing ahead of time what it's going to have to be doing.
yeah, that's a good question.
It's not the particle itself that the individual particle does not make an interference pattern. It's their collective impacts over time. This kind of stuff. This is what you would see at the detector over time build up. But the individual impacts are always only one spot.
I'll tell you the truth. I've never seen. Have you ever seen a double slit experiment conducted
Yes. Yes.
with a
You
single
probably
photon?
you probably didn't. Yeah. Well, you probably didn't search enough on your YouTube trips But Veritasium has done a double slit experiment with individual single photons.
No, he didn't.
Oh, yes, he
I
did.
know. I know every single YouTube double slit
Every single
experiment.
one.
Yeah. Show me Veritasiums.
Do you click play in your mind and you can see them all?
I know them all. I've been through them multiple times. I have videos about going through every single YouTube video about every single double slit experiment multiple
Here you go.
times. You have
With
it?
timestamp.
Fine, let's see it. Is it the
And
one
you
with
get,
the box from 11 years ago?
whatever. So
Is
what?
it? That's not a single photon.
That is a single photon. You've got a
No, it's
detector
not.
there counting photons, and per second it only shows something like 3 to 7 photons being received at the receiver.
Let me see. Okay, maybe I'm wrong.
He even says that.
Let me see. You have it? You put it? Mhm. Where is it impacting? Where's
On a
where's the
photo multiplier tube.
does he show it?
I don't know if he has an actual direct shot of the entire pieces, all the pieces individually. It's like a 213 roughly. Yeah, about
Yeah, I
213,
mean,
220. What, are you trying to now accuse him that he's not actually performing the experiment correctly?
I'm not accusing. I'm completely open-minded. I'm trying to. I'm honest. I'm trying to understand.
Well,
I'm here to be disproven. I'm not here to be proven.
well,
So
feel
where
free
is
to.
so okay? Let me understand the apparatus. So
There's a very weak light source on one end, an enclosed tube with a double slit, and on the other end is a photomultiplier tube.
what's a photon multiplier tube?
Photomultiplier tube.
Right.
I
So
It's another way you could use as a CCD. It's another type of sensor which lets you detect individual photon interactions.
So I haven't read it, but I just posted a link to a science journal called "Video Recording True Single Photon Double Slit Interference."
mhm. So your question is, how can it be that the slit is big, but the detection is tiny? How do we know that the entire energy of the photon is in localized to one spot? What do we know about this detection?
Well, we know it can detect individual photons. That's what we know
How do we know?
because we've tested it.
How did you test it?
I
What is
don't
it?
really know how the CCDs work. Presumably, they're able to do it.
CCD, if I'm not mistaken, is just the photoelectric effect from Einstein. A
I
photon,
don't remember
photon just,
exactly.
I think a photon just releases an electron. And the electron causes current. So that's the detection.
Well, yes, it is a electronic device. Yes.
I'm saying the way to convert a photon into a detection is through the photoelectric effect, I think.
Yeah.
So,
So.
no, I'm just trying to, because he's not explaining the mechanism. So I'm just trying to understand it. Because you're saying, okay, I don't have, the truth is, I just don't have enough information. I mean, this is something I've
Okay.
been looking for.
So you're trying to you're trying to discredit the experiment instead of trying to provide an
No,
experiment
no,
explanation for it.
no, I'm
Yes,
not.
yes, yes, yes. That's what you're doing right now.
Oh.
You're trying to look for some sort of a loophole that allows you to say that no, the photon didn't really go through both both slits at the same time, or there's some other problem
No,
with the
no,
experiment.
no. So I'll tell you my theory. So look, I come from a place where I say science assumes the universe is mechanical, intuitive, understandable to a child. That's my definition of
Eh,
science.
Right,
That's
yeah,
my
and
definition. This is what this discussion is about. So based on this assumption, I'm trying to explain the evidence that you're presenting. So the photon to me is a wave. That happens to be true because of the ether. Photon must be a wave. Everything must be a wave. So let's assume it's a wave.
Huh?
Anyway,
I think that what was that was the like oh my god, that was the biggest jump in logic I've ever heard in my life.
Yeah, can I ask why science should be explainable to a child? We don't expect
just
them to understand law.
it's just my definition of science.
Hey, don't
Science
bring
must,
me into this.
Mac and cheese, you get on the mic right now, bro. Get on the mic.
anyway,
Well, if it's explainable by a child, can't you explain it so you are talking to a child?
oh,
I
that's
I
just the
just
definition.
posted the video from the article that I posted showing a single photon by single photon double slit experiment.
But how do you know that's a single photon?
Read the article and tell me.
No. So I mean, you tell me. I mean, you're presenting the evidence, so you need to read the article and tell me.
As I said, okay, whatever, man. So you're saying that this article is lying.
No. No. Well, no. Stop it. No, no, no.
The title, hold on, the title of the article is literally Video Recording True Single Photon Double Slit Experiment. And
Yeah,
you're
but I'm
telling me that it's
asking.
not single photon.
No, I didn't tell. I asked, how do we know? How can we know? I'm being skeptic. I'm being skeptical. I'm being scientific. How can we know what we're being told? How can we validate, verify, whatever? 'Cause in my mind, what you could have theoretically is you could have photon going both slits. Apparently, it's going through both slits. A single photon. If we're able to, the first question is, are we really dealing with a single photon? Going
So
Yes.
through
my question for you is this then. If every single quote unquote photon emitted is its own individual wave, then why in the video that I posted does it exhibit as individual dots appearing on the detector one at a time?
How do we know it's one photon and not two?
How is it that you can have a wave be produced that appears on the detector as a single dot and not a wave on the detector?
Maybe it's tiny. It's a tiny wave.
Sure, if you want to go that way, call it a tiny wave. Then you have to
It's
explain why
actually
that tiny wave
right.
went through two separated slits at the same time.
It's a ultra mega gamma ray that basically acts like a particle and a wave at the same time or something.
Yeah, there you go.
No,
I'm calling it, dude. You said that you understood quantum
no.
mechanics, and I'm saying right here, you are an example of somebody who thinks they understand quantum mechanics does not understand quantum mechanics.
Right.
And
That is.
certainly would have known what a photomultiplier tube was.
Um. So let's say a photon So you're saying a photon is not big enough to go through both slits? It's too
Well,
small?
the slits are separated further apart than the individual detector pixels are. So, what gives?
What
And
if
each
Mhm.
detection only trips 1 pixel.
Okay. So
So
what
whatever hit
if
it must be smaller than that.
okay. What if it's coming in as a wave that is spread, but as it's interacting with an electron, it's like being sucked into that electron. Right? Because ultimately it's trying to pick up an electron from its from its atom. It's trying to
So
dislodge.
your packets of electromagnetic energy and wave energy now are smeared out, but they collapse to a single point once they interact. Did you just reinvent quantum mechanics? Like you've literally just described the wave function and the collapse of the wave function.
There's no particle. It did all of that with no
Sure,
particle.
call it whatever.
Everything.
Call it a shmoo if you want.
No, no. It's if we just did that, if everything fits the data and we were able to do that without a
Well,
particle moving through
you just
space.
postulated the hypothesis that somehow the photon, which you call packet of wave ether or whatever, went through both slits, but on interaction with the detector collapsed to a single point, to a single electron, whatever. I mean, you literally just reinvented quantum mechanics and the fundamental principles of the wave function and the collapse of the wave function. So good job. Welcome to quantum mechanics.
No, I did it mechanically. Everything in my mind, what you
Totally
just said.
mechanically.
Right. So ask me anything.
That is literally quantum mechanics. That is how it works.
And ask me anything.
What is the mechanism by which this wave produces a single dot on there, but still interacts with all of the other single dots to produce a interference pattern?
doesn't interact with the other dots. It goes
Then why
through.
is there an interference pattern that is created by multiple little dots?
Well, when a photon, that's easy. When a photon goes through the slit, it's smeared out. It behaves like two different waves that are coming out of the two slits. They interfere with each other, but it's still maintaining its integrity. It's still one unit, even though it was just split up by the slit or by the barrier between the.
But didn't you define your photon, your little wave packet, as having a definite location?
No,
Yes, you
it's a
did. You
wave.
said it has a dx. It has a
Yeah,
A
position.
discrete dot is a definite location.
Yes.
No, it's a dx, like Heisenberg's uncertainty. The
Okay, so
wave.
how big is that dx?
Well, big enough to go
Could it be
through
a
both.
meter?
I don't know, but it's big enough to go through both slits at the same time.
So how do you define that dx?
I want to get a question or a statement in.
Go ahead.
When I'm looking at these images of the double slit, to me the light going through and then coming out as these patterns is like a refractive pattern, like how our rainbows are formed. Is there any similarities?
It's an interference pattern. So it's like two waves that are overlapping each other. And
So
where the
is there any refraction involved, or
no, this is more diffraction. This is a different type of effect.
right? Okay.
Refraction is the change of direction of light. Diffraction is where light, or any wave effect, in fact, that goes through a hole that is smaller or comparable to the size of the wavelength, will, on the other side of the hole, spread out in sort of a semicircle. And that's why
Okay. So depending with compared with light and a wave, it's because it's a wave. It does that. Yeah, I understand what a wave is.
yes, light behaves as waves for the purposes of diffraction and interference. Yes.
Right. Okay.
But on detection, it always collapses down to a single point. Each photon only presents itself as a single point. The trick for the double slit experiment is that even if you fire individual photons, which obviously at the detector only trigger 1 pixel, only hit one very definite point, yet they still produce, even if you fire them in sequence, they still produce this interference pattern. So it's behaving as if the photon went through both slits and interfered with itself. That's the paradox, so to speak, of the double slit experiment, or the sort of mind-bending part of it, which our intrepid quantum physicist here has yet to explain with this theory of ether, which apparently has a definite position for a photon, yet it can also go through both slits at the same time.
Is that where the phrase that the particle and a wave come into it, or is that something different?
Yes, this is a direct demonstration of wave-particle duality.
Right. Okay, back to the conversation.
Right. So let's say how do we know that it's a single photon that's coming out from the emitter?
You're looping back. It's not a question of a single photon coming out of the emitter. It's a single photon being received by the receiver.
How do we know? Maybe it's multiple.
Well, you can remove the slit if you want, and then you can just count it directly on the photomultiplier tube or on the CCD, and they'll still come out as single photons. So, and we don't care about the photons that do not go through the slits. We care about only those that go through.
So it could be that each dot is really multiple photons.
No.
Why not?
How would they recombine always in the same spot? How would you have
Photonic,
two?
yeah, photonic reattraction.
By
It's
what
always
mechanisms would they always recombine to the same spot, even if you have multiple of them?
so it's always the experiment, the way it's conducted. We fire a single electron, because I see multiple dots appearing in every timestamp. It's not a
That's because
single.
it's a time. That's because this is a time lapse.
So the question is, what actually is it one by one? Is it like
Yes.
each time? Okay. So
Yes, it
each
is one
time.
by one. The experimental apparatus typically is about a meter long. So by the speed of light, you know that the photon takes like a fraction of a nanosecond to get there. So for even if you detect like 10 detections per second, that means that for the vast majority of that time, there was no photons traveling through that slit, and just occasionally one of them blips through. It's just it blips through so fast that if you count them up per second, they get to multiple detections per second. It's still a very low number, and yes, they still fly by individually on their own.
Okay. So a single photon goes through. For each photon that goes through, we always get a detection.
Pretty much, yes.
Sometimes we don't.
Well, the detector is not, it isn't a completely enclosed hemisphere around the other side of the apparatus. Occasionally, they might fall out, away from the detector, but we don't care about those. We care about the ones that do hit the detector, which is still, even if you accounted for all the ones that don't hit the detector, still nowhere near enough. It's not like there's this mega stream of particles and just occasionally one of them hits the detector. No. Most of the time there's nothing going on. Sometimes a particle goes through, and maybe on occasion it doesn't hit the detector. Most of them will, though.
Okay. So we fire a photon. What's the size of the thickness between the two slits? Do you know?
Typically they'll be a few millimeters apart at least.
A few
But
millimeters? No.
Yes, but they can be even further apart. As far apart as you need them, really, for the size of your experiment. They could be meters apart if you wanted to make a really big one. But typically,
How?
they'll be a few millimeters apart.
What do you mean a meter? Meter apart?
If
How?
you wanted to make a very big version of the experiment, you could put them meters apart, but then you would have to have a giant CCD on the other side. So typically, they'll be a few millimeters apart.
What would you fire?
Photons. Still
How
the
do
same
you
thing.
fire? How do you fire a single photon? Would it be a radio wave photon?
No, it'll be visible light.
Visible light? Visible
Yes.
light is tiny. The
Yeah,
wavelength is
I know, right? Funny, huh?
what?
It's only a few hundred nanometers.
It's red light. What is it? I don't remember. 65 nano or something, or
It's about
6.4?
700 nanometers.
Okay. So, so you fire a single red light photon, and you're saying you can have your slits as far apart as you want, even
Pretty
with red
much.
light? Even with red light?
Yes, pretty much. You would still get an interference pattern. You just have to have a ginormous detector and wait for a very long time to accumulate enough of them to make a nice pattern. So typically the detector is much smaller. You know, the slits will be a couple of millimeters apart, and you'll have, you know, a few dozen square millimeter CCD on the other side.
Have you ever seen this? Has anyone ever done this?
Veritasium videos literally shows you that device and how it's detecting. He uses a
Meters
photomultiplier tube. And by the way, the video that Felkami posted for you, that is from another experiment. So yes, people have seen this.
So there's a Veritasium video where he fires a single photon. It goes through two slits that are meters apart.
No, not meters apart. Typically, they'll be millimeters apart. But the principle holds. Nevertheless, it's already tens of thousands of times larger than the wavelength of the photon, so that's not going to save you.
You're mentioning a second ago about the color of the light. Does that make a difference compared to white light and
No,
you
not
said
really.
red?
Well, white light is just a combination of different wavelengths. It's easiest if you
Yeah.
have just monochromatic single color, single wavelength light.
Okay.
Typically, you want a sufficiently high frequency or short wavelength such that you're not going to get into some other scattering problems. With radio waves, you could actually use much larger gaps. Radio waves have wavelengths much bigger. So you could end up with, you know, the slits wouldn't have to be very small. In fact, diffraction of radio waves is one of the ways you can actually receive a radio wave, like standing behind a building, even though the transmitter's on the other side of the building. But then it gets really messy.
Has he explained yet why the waveform collapses if you're observing it or not?
No. So far, he's still in the denial phase.
No, there's no denial. I mean, I never had this data to contend with, and usually it's impossible to talk to people about this. So this is the first time I'm having a conversation about this topic.
Well, I mean,
So
I applaud you for rediscovering quantum mechanics from this data. So that's a good thing.
yeah, I mean,
And wave function collapse. So that's another good thing.
Yeah, wave function collapse when you observe it. Interesting.
Yeah, I mean, you're literally, dude, you're almost right there. You just refuse to take the last step. You already said that what if the photon goes through both slits, but when it interacts with the detector, it collapses into a single point. That is quantum mechanics.
I
We
mean,
just
if
call it different
that's
names.
but the question is, what's the mechanism by which suddenly something so big collapses into something so tiny?
Yeah, and that is where you get to the wave function.
The interpretations, right?
Yeah, I mean the interpretation is if you like you do whatever you want, but that's sort of between you and your God. But the mathematics of the wave function do give you this.
The
Well, the wave function.
mathematics of the wave function gives you what?
It gives you a probability distribution that you're going to find the photon at a specific point. You just run the math, crank the handle on it, and out comes a prediction. You compare the experiment, and it is extremely highly precise. And I'm just laughing at the sea lion meme there.
I'm stealing it. I like it too much. I'm stealing it. That's good.
I didn't see anything. Anyway,
What I missed, I was too busy reading.
No,
The train with the bus. That's a good one. I like
Oh,
it.
okay.
anyway, so you're saying that you're firing a single electron
Single photon, yeah.
Single photon. It goes through 2 slits. You don't care what the distance between the slits is. That
Well, that has to be small, right?
The distance it just depends upon the size of your detector. You can make the separation between the two slits as big as you want. It's just then you have to have a ginormous detector on the other side. I'm making a I don't know when the last time was that you priced out the CCD, but CCDs and silicon, by the meter is a little bit expensive to come by.
okay. I'm a little bit confused about this experiment that you're describing. So
I can believe that.
don't be mean. Come on, stop.
I'm not.
Anyway.
I'm following along as we're talking and asking the right questions.
I wasn't referring to you. I was referring to Tortoro. Anyway, so I don't understand the experiment where you're saying you can separate the slits as much as you want by a couple of meters. I can't imagine such an experiment.
Well,
saying-
then just think of the one that is actually presented to you, where the slits are separated by a few millimeters.
I mean, I want to have as much data as I can. I mean, if you can separate it by meters, that's how.
Yeah.
I can't imagine that.
And even light years in principle, if you wanted to.
How? But you need to fire like light in the direction of the 2 slits. So how can you
So,
have them separated by so much? I mean, I'm just trying to
so
imagine.
so just
I'm just
you just use a light source that is, sufficiently positioned in such a way that you're only sending photons down to your targets.
right. So
I mean, it's a
using a
question. Your
beam.
question is like, how do you shoot a light beam through 2 slits that are separated by meters? It's like, well, just you point it that way. What's the hard part?
Like with a beam splitter?
No.
Okay, I have a laser pointer, right? That's not gonna work, right?
Laser pointers are typically not used for this because you want individual photons, and lasers do not work with individual photons.
Well, why
Okay.
not? Do they put one big photon out?
What you want for this single photon experiment version is a light source that is very low intensity, such that you can basically just get individual photon emissions.
Oh, so you could use a laser and filter it and filter it and filter it until you had the rate you
To just
wanted, right?
put it through a
Yeah,
sieve.
that's amazing, Jesse. I wonder if somebody could have done that.
So what is the light source for the when the 2 slits are meters apart? I don't get it. What do you use?
I think they use a low intensity thermionic valve.
Okay, and in English, what is
On the
that?
retroencabulator?
It's basically a vacuum valve, vacuum tube, run at very low power.
Is that the precursor to the turbo encabulator, Nessa?
No, it's the thing you used to have in a radio back before transistors.
Does it emit visible light?
Yes.
What color?
It depends upon the temperature.
So it emits a single photon?
You can apparently tweak them in such a way. I'd have to check the exact
Wait,
type that
you
you
don't
use.
know what a vacuum tube is, MrSlave? What?
Evidently, he doesn't.
It's a vacuum tube?
Yeah.
Or a valve, if you prefer the British version.
Yeah. The stuff we used before transistors, you know?
Isn't a vacuum
Cool.
tube doesn't a vacuum tube emit electrons?
It allows the flow of them. You can control the flow of them. It's like a shitty transistor. It produces a ton of heat.
Yeah, but it gives off electrons, not photons.
It doesn't give off electrons.
Well,
You have to you flow electrons through the vacuum tube, and you're able to shut it on or off. Like I said, it's a shitty
Yeah.
transistor.
So
in the single light experiment, they used a thing called a BBO crystal.
BBO crystal? What?
Yeah, as a source for the light.
Was a crystal a source of light? Like they heat up? Why
Yeah,
is it?
it appears to be a
Why do you need? Why do you need such a strange source of light in order to do the double slit experiment? I don't get it.
because you want it to be able to emit photons of a certain wavelength, but of extremely low intensity, meaning they're very low number of them.
But couldn't it be argued that a non-coherent source like that depends on the random-ish capturing of electrons by molecules or atoms could create kind of an already quantum light pattern, as not only in timing but also phase angles and stuff, that maybe it's not, I mean, if we're basically using a quantum technique to produce the light, and then we're using a quantum technique to detect the light, how do we really know that it's the light itself that's quantum, or just our production and or detection methods, right?
You lost me there with halfway through the question.
That's a bad sign. That's a really bad sign. Do you even know what we're talking about?
Anyway,
Sorry.
okay. Anyway, so you're saying we're using a valve in order to create low intensity, very few photons of a visible light. Then, okay, and then you have two slits meters apart, yet you're able to make sure that it's basically only one photon at a time being emitted, and then you're seeing the detection. You're getting a double slit, and you're getting an interference pattern. You need to see it. Anyway, but do you have any links to that experiment, to anything, any more
Dude,
information?
Falcami literally posted a link to the paper.
Hmm.
And then he posted it again. Maybe
What's
he'll
the
post it a
name?
third time.
Alchemy?
Here you go. Here it is a third time.
Okay. You. No, the one that's meters apart.
I never said that I had an experiment that's meters apart because it is not practical.
So how do you know it would work?
Totoro's lying. Oh my god.
How do you know? How do you know meters apart would
Dude, you're
reproduce?
literally trying to deflect away from the problem. Your problem is that even with the real experiments, which are gap spacings of millimeters apart, which is still way larger than the wavelength, you have no explanation. So let's focus on the thing that we have experimental data for, which you have no explanation for.
Look,
Then we can
I'm
quibble
fine.
about other theory.
Fine, you brought it up.
I
Look,
said
I'm
the
trying.
principle
Fine. All
applies.
I'm saying, I thought that was an actual experiment because I wanted to go like to the hardest question. What's the point of dealing with an easy question? I want to get the hardest question.
You already can't answer this question. So let's go with the one that we have experimental data for, and
I
then we can
mean, so what
generalize.
honestly, okay, so what's the question right now? So you're firing, okay, so in a real double slit experiment that you want to discuss,
Yes.
tell me, okay, let's go through the data. So were they using for light source like a laser, a red laser? Something
Yes.
else? A laser? Okay.
They're using that BBO crystal stuff.
The BBO crystal. Okay, so visible light, very low intensity, so very few photons, basically one at a time. Each time they were getting only one detection, and they got an interference pattern. And it seems like photon went through both slits, but when it decided to interact with an electron, it collapsed, it got snatched up by a single electron somehow.
Yes.
An electron sucked it up, which
Well,
is
or sucked it off if you want to use that terminology. It really
right.
doesn't matter. It interacted with a single electron. Oh, well,
Which
it interacted at a single location.
which is weird. I mean, it's not a location. I mean,
It's
it is.
weird. Yeah.
Yeah, okay, fine. Yeah, it's weird. I mean, it's not a point. It's still a region. It's still an orbit. It interacted with an entire electron orbit, and it pushed it up. But the question is, something so big that can go through two slits simultaneously suddenly interacts with a
Only
thing like
one spot.
it's like
It
the
trips
size,
only one pixel on the CCD. That's the trick.
which is an electron, which is a single atom. A single atom, you don't even know if it's a single atom. You know what? But it's even if it's a region, it's even worse. How do we know? Like a CCD pixel, is it a single atom? I don't think so. What is it? What is a pixel?
It's a single light detecting device.
Right, but what is it? I need to know the mechanics. I mean, it's better. We look for a good analysis. We need all
It
the data
doesn't
we have.
it doesn't matter what it is, as long as it is smaller than the separation, and we know specifically that it is. It's only basically one spot. And it
Okay,
interacts only in one spot, but it goes through both spots.
Well, we could go over what it is. If it's a CCD, it's an electron well. It's basically a photodiode coupled to a capacitor, and every time a photon hits the photodiode, it pushes an electron into the capacitor, and it's called an electron well.
Yes, but it's the smallest detection unit that the CCD can detect. And no, it's not a single particle or a single atom or a single electron, nothing like that.
So can you explain again the mechanism of the detection?
Dude, research what a charged coupled device is.
Charge coupled device?
Yes,
Charged?
that's what that's what the word or the acronym CCD stands for.
Okay. Charge coupled device is a light sensitive integrated circuit. Captures images by converting photons to electrons. It consists of a layer of insulation over substrate with electrodes or taps on the insulated material. As these electrodes from potential wells where charged. Okay. I'm gonna need to watch videos about this. Anyway, so what are we
How about you read a
assuming?
paper about it instead of
Yeah,
watching YouTube?
I mean, yeah, it doesn't matter what I do until I'll do whatever I need to do until I understand enough in order to feel comfortable that either I have an answer or I don't have an answer. So the question is, okay, so it goes through both slits. Look, that I don't know if that has anything to do with the wavelength. I mean, the way that I mean, the
Well,
photon.
the sizing and the separation of those slits has to be matched correctly to your wavelength, because otherwise you're not going to produce a diffraction pattern and an interference pattern.
Okay, I'm saying the way the photon works, right? It goes up and down or whichever way, and 90 degrees to that is the magnetic wave. So um,
It's not just a wave, though.
what do you mean? What do you mean it's not just a wave?
Oh,
It's an electromagnetic wave.
it's also a particle, though.
I don't know what that means.
Well, it means that if you fire a beam of light, a photoelectric, you can kick electrons out of the orbit. It has momentum.
Yeah, but that's not a particle. You can
It is a
have
particle.
momentum. No, and the way if you read Maxwell, you see that the EM wave has momentum without being a particle. So Maxwell agrees that EM has momentum, so you don't need a particle for momentum, according to Maxwell. So anyway, you have
So they act like particles, but they're not particles.
don't act like particles
They
because
act like
there's
particles.
no
Yeah, they do act like particles. They're
how.
individual when you fire them at the double slit. They're individual.
Yeah,
hit.
they have one definite location. They do not spread out. But before
Yeah.
before they impact, they did behave like they were spread out.
Right, but they hit as individual particles, but the
Yes.
particles are in the waveform. It's like a
Yes.
Okay, but the way I see it, nothing was moving through space except for the propagation of the energy was
well, right.
moving
But we
through.
fire an
You
individual
want to.
particle, and we notice an individual particle hit the detector. In the meantime, though, it behaved like a wave.
Right, but at no point was there a particle.
Well, wait
It's
a minute.
not a
We
particle.
fired a particle out of the gun. We noticed the particle hit the detector. Yet in
No,
between, it acted like a wave.
no, no, no. You never fired a particle.
We did.
You
We
never
fired a
did.
particle. We fired an electron.
No, no. We're talking about a
A single
photon.
electron.
We're talking about a photon
Let's
right now.
let's
No,
let's
no.
let's ignore NASA. Let's not talk about how we emitted a single particle. Let's talk about the fact that we only detected one particle on the other side. Yet they
Okay.
all
That works
behave.
too.
Yeah, yet they all behave as if they were a wave that was spread out.
Okay, look, the only question is, all the information we have is that it's a wave. At no point did we detect a particle. The
Incorrect.
fact that,
Well,
wait, let me finish.
we detected an interaction only at a single spot on the detector. If you want to call that a wave packet, be my guest. Wave packet in your language is just particle, what we call a particle.
Okay, so hold on. So it's weird that we detect a single pinpoint location.
It
That
Why?
is.
is,
Why is it
yes,
weird?
yes. Let me just finish.
I
Let me
mean,
just
it's
finish.
weird, but it happens.
Yeah, hey NASA, Totoro's got this. Can you give him some room? Give him a free line. He's doing a very good job. He doesn't need your help. Thank you.
Yeah, NASA being a cuck as always.
Anyway, look, my point is that even with the weirdness, even if I would submit that there is a weirdness to the collapse of the wave, it's
Function.
still wave.
Sorry, I was just
Even
completing your what you wanted to say there.
okay, I don't agree with your completion, so I'll start over. So even if I agree that there is a weirdness that the wave
Function.
NASA, shut the fuck up.
collapses into a single location, that is still not my definition of a particle.
Sure,
So,
that's fine. If you want to define terms differently, that's okay. We're just gonna say that the wave collapses into a wave packet, where a wave packet is what we normally call a particle. That you call it wave packet, so let's use your terminology there, wave packets. So we
no, no,
fired
no.
an individual wave packet. It
Let me
goes
just
through both slits, and
let me
we only detect it as a single wave packet.
hold on. No, 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 no. You're misexpressing the way I would express it. So let me express it. But before that, let me tell you the importance of the distinction. So I never had a position about quantum mechanics, GR, SR, anything. I never had a position. I wasn't in this universe. It was not my place. I research other fields. Anyway, until 2-3 months ago. So 2-3 months ago, I came to the realization that there is ether. That ether comes out of Newton's equations of gravity. Once I realized that, I couldn't figure out how there could be particles in a universe. where ether is flowing so fast.
You're not really trying to explain the double slit experiment. Anyway, I gotta go here. It's past 4 a.m. for me, so
Oh.
have somebody else have fun with them for the rest of the day.
Good work, man. Sleep
See you,
well.
folks.
Thank you, Totoro. Thank you for your time.
Jekyll, are you here?
Thanks, man, for the chat.
Jekyll, coming in. Jekyll.
Did C-Line talk to you guys and ask you to finally be productive with me?
No.
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 He didn't.
God. Put a ticket on yourself, champ. Wow. Do you think we just obsess about you? You don't live in our head rent free, mate. Don't even kid yourself in that department.
MrSlave has been living in my head rent free.
You're kidding. You might let him in.
Speak for yourself. Speak for yourself, Bula.
Okay, well, geez, you guys give away free rooms.
Okay, let's get it. Got a little time on my hands like a wristwatch. I don't got time for the breaks and the pit stop. Race through the gridlock, take it like Chris Rock. Right to the chin, still win. Heavy metals like Slipknot. Got the driving, I got tunnel vision. I just hit my stride the way I run the business. I've been making paper like I'm Dunder Mifflin. See the end game, I got one division. Look, I don't ever bother with a critic. Hit him with a chronicle of Riddick. Boom, bottle full of Ritalin. I hit him with a little bit of riddle me this, riddle me that. My bad, fell asleep at the gas. No time to wait though. Elon Musk, I'm trying to bankroll. New Tesla just cause I say so. Electric whip like Ivan Vanko. I just did it. W's only, you know I've been winning. Top of the world, the globe is spinning. If you know, I've been on a mission. Okay, let's get it.
I've been on a mission like totally spice. I'm baddie, she bad, but she totally nice. Nails are blue and her toes feel like white. They complete me, match out at the soul for my leg. He knew it for sure, but he left with a why.